Okay, so for problem 10, it says use a convergence test to determine if each of the following series converge or diverge. Now, I'm going to start with part B just by looking at um, the series here. For part B, what I recommend to use is the test for divergence. If you recall, the test for divergence states that if the limit goes to zero, if the limit is not equal to zero, then the series would diverge, right? So here's our series again: n equals 1 to infinity of x to the fourth minus 10 over x to the fourth plus 9. So this is my sequence, this part, that's my an. So if I compute the limit as n approaches infinity of an, which is precisely the limit as n approaches infinity of x to the fourth minus 10 over x to the fourth plus 9, one should be able to see that this limit goes to 1 because the degrees are the same. So you take the ratio of their leading coefficients, which are both 1, so 1 over 1 is 1. Now, since 1 is not the same thing as 0, we can say that the given series diverges by the test for divergence. And boom, you're done with part B. For part A, what I would recommend to do is use a limit comparison test. Now, for part A, I'm just rewriting the given series, right? So n equals 1 to infinity of x to the 1/3 minus 10 over x to the 4 plus 9. Again, that's our given series. Now, I want to make a comparison series. We will make a comparison series by just ignoring the constants and looking at the ratio of the variable terms. So here I'm going to format or formulating the compared series. So again, just ignoring the constants, we have the series from n equals 1 to infinity of x to the 1/3 over x to the fourth. Now, you're just going to do a few rewrites to this. What you can do is, since your bases are the same, you can subtract the exponents, 1/3 minus 4. Now, because I'm running low on time here, I'm just going to say what that answer is. So 1/3 minus 4 is negative 11 over 4. And you could rewrite this now using positive exponents. You'll get 1 over x to the power of 11 over 4. This value, 11 over 4, is your p. So you have a p series where p is equal to 11 over 4, which is greater than 1. So what do I know about this compared series? Will the compared series converge or diverge?
Converge.
Yeah, this series here is convergent, right? It's a convergent p series because p was equal to 11 over 4, which is greater than 1. Now, what I want to do here is I could use a direct comparison, but the part that I hate about direct comparison is showing that one series is always smaller than the other. So instead, I do a limit comparison. Just show that a limit exists and both of the series will converge. Well, yes, in this case, both series will converge. If the compared series was divergent, then the limit still has to exist to explain why the given series would also diverge. Okay, so now we're going to take the limit as n approaches infinity of the given series divided by the compared series. So this is the way I'm going to write it. We'll say x to the power of 1/3 minus 10 over x to the power of 4 plus 9 divided by 1 over x to the 11th over 4. Now, instead of dividing by the compared series, we can multiply by the reciprocal, right? So this is now equal to the limit as n goes to infinity of just rewriting the given series times x to the power of 11 over 4 divided by 1. So we'll have the limit as n goes to infinity. You can multiply this out straight across. X to the power, sorry, this shouldn't be 11 over 4. That should have been 11 over 3. So let me fix that. Oopsie. So x to the 1/3 times x to the 11 over 3 is x to the power of 12 over 3. But x to the power of 12 over 3 is just x to the 4th minus 10 x to the power of 11 over 3 divided by x to the 4th plus 9. Now, since your highest powers are the x to the 4th, you're looking at this ratio, your limit is going to equal to 1. So the limit exists, it's finite, it's positive. So we can conclude for part A that by the limit comparison tests, so you have to write a statement like basically what tests you use. So we use the limit comparison test. And because we showed that a limit did exist, it's finite, it's bigger than 0, then the given series for this problem, part A, will also converge. And that's it to problem number 10. Okay, so use a limit comparison for part A, and part B use a test for divergence. My recommendations.